Yes, hello my dear students. Welcome to my channel Sri Vlogs Fun and Entertainment. Right, today we are going to discuss one most important topic of Unit 3 P&S, Probability and Statistics, which is continuous distributions. Right, continuous distributions. Already we know what is discrete random distribution in second unit. Discrete random variable is nothing but if the variable takes the values 1, 2, 3, so on, it is said to be the discrete random variable. If the values in a certain range, that means if we take 1 comma 2, all the values in between 1 comma 2 also exist, then it is said to be the continuous random variable. So there is a distribution called normal distribution. This normal distribution is for continuous random variables. Okay, we will discuss this normal distribution in today's class. It is very important. So normal distribution is the most important, powerful of all the distributions in statistics, isn't it? Normal distribution is the most important and powerful of all the distributions in statistics. It was first introduced by De Moivre in 1733 in the development of probability. So here normal distribution is a limiting case of binomial distribution, right? So in binomial distribution, n value is finite, okay? But in normal distribution, the number of trials are infinitely large, n tends to infinity, and neither p or q is very small, okay? So both p or q are not very small. That means they should be finite value, right? So in this case, we apply normal distribution. So the definition of a normal distribution is a random variable x is said to follow a normal distribution with parameters mean mu and standard deviation sigma if its probability density function is given by f of x comma mu comma sigma equal to 1 by sigma root 2 pi into e to the power minus 1 by 2 of x minus mu by sigma whole square, where minus infinity less than x less than infinity, minus infinity less than mu less than infinity, and sigma greater than 0. Sigma is nothing but standard deviation, mu is nothing but mean. So in normal distribution, mean and standard deviation are the parameters. That means normal distribution is depends on mean and standard deviation. Okay, so this is the definition you need to remember. F of right. Now graph of normal distribution. This is very important in normal distribution. The normal distribution of a variable when represented graphically takes the shape of symmetrical curve known as normal curve. This curve is asymptotic to x-axis on its either side. What is asymptotic? Asymptotic is nothing but it is a tangent. It touches the x-axis at the point infinity. That means we don't know where the line touches the x-axis. So it may touch at the point infinity, then it is said to be the asymptote. Tangent at the point infinity is said to be the asymptote. We learned in our it is in our intermediate level second year. So here the normal curve, the curve is asymptotic to x-axis. That means curve may touch the x-axis at the point infinity in the left side and infinity to the right side. Okay, this is the normal curve, and mean and mode and median 3 are equal for normal distribution. So this is the point mode. That means the highest probability, the point which is having the highest probability. Where the normal distribution having highest probability at the point mean x is equal to mu, The normal curve has highest probability, so this is the peak point of the normal curve. Okay, so and the remaining cases, the curve is like this, right? This is the shape of the normal curve, right? So some important properties are there for normal curve. We'll see those properties. So the chief characteristics of or properties of normal probability distribution and normal probability curve. The normal probability curve with mean mu, standard deviation sigma has the following properties. The curve is bell shaped. Already we have seen that. So this is the normal curve is always like this. Okay. The curve is bell shaped and symmetrical about the line x is equal to mu. Okay. Symmetric means how much part from the left side is same. The part for left side is equals to the part n of left right side. Okay. So this is the point x is equal to mu. So this side is 0.5 as well as this side is also 0.5 because the mean, median, mode 3 are equal for normal distribution. The mean, median, mode of the distribution coincide. So this is said to be unimodal distribution also. Normal distribution is also called unimodal distribution. Okay. X-axis is an asymptote to the curve. Already we have discussed it. No portion of the curve lies between the x-axis. Okay. So all the probability distribution lies above to the x-axis only. There is nothing lies below to the x-axis. This part contains no probability distribution because we already know f of x being probability distribution, it is not the negative value, right? So these are the inflection points. We call it as inflection points. So see here, x is equal to mu. X is equal to mu. We take it as base point, and mu plus alpha, mu plus 2 alpha to the right side of the mu, mu minus alpha, mu minus 2 sigma, mu minus 3 sigma are the base points of a normal distribution. These are called inflection points. Why these are called inflection point means the most of the probability lies between these 2 points. These points. That means if you take mu minus alpha, mu minus sorry, it is called as uh, sigma, not alpha, sigma, mu minus sigma, mu plus sigma. So in between these 2 points, almost 68% lies in between these 2 points. 68 point. Like that, mu minus 2 sigma, mu plus 2 sigma, 94 point approximately, and mu minus 3 sigma to mu plus 3 sigma, 99 point, I think. So this is that's why these are called the inflection points, right? So the curve of normal distribution has a single peak, that it is called unimodal. Already we have discussed it. As x increases numerically, f of x decreases rapidly. The maximum probability occurring at the point x is equal to mu, which is given by p of maximum is equal to 1 by sigma into root 2 pi, right? The total area under the normal curve is equal to unity. The probability percentage distribution of area under the normal curve is given as about 68.27 percentage, as we discussed before. 68.27 percentage of the area falls between mu minus sigma to mu plus sigma. Okay, P of mu minus sigma less than x less than mu plus sigma is equal to 0.6826. The area under mu minus sigma to mu plus sigma is 0.6826. Okay, so if we say this is mu minus sigma, it is mu plus sigma. Our bell-shaped curve consisting 68 point, and this area includes 68.26 or 0.26 0.6826 0.6826 percentage lies between these 2 points, right? Like that 95.5% lies between these 2 points, and 99.73% lies between these 2 points, right? So we have shown in this graph clearly. So mu minus sigma to mu plus sigma, the area is 68.27 percentage. Mu minus 2 sigma to mu plus 2 sigma, the area is 95.45 percentage. And mu plus 3 sigma to mu minus 3 sigma to mu plus 3 sigma, there is a 99.73 percentage. And one more important property for the normal distribution is standard normal distribution. Standard normal distribution, which is also very important. A random variable z is equal to x minus mu by sigma follows the standard normal distribution when we give specific values to mu and sigma. It is said to be the standard normal distribution. The specific values are 0, 1. Mu is equals to 0. The mean takes the value 0, 0, and standard deviation takes the value 1. Then the normal distribution is said to be the standard normal distribution. Please remember it, very important. So its probability density function is given by f of z is equal to 1 by root 2 pi into e to the power of minus z square by 2, where minus infinity less than z less than infinity. The area under the standard normal curve is equal to 1. 68.26% of area under the standard normal curve lies between -1 to +1. Okay, 95.44 percentage of the area lies between -2 to 2, and -2 to -2 less than z less than 2 is equals to 0.9544, and 99.74% of the area lies between z is equal to -3 to +3. Clear? So we have represented it. Now we'll see one problem of a normal distribution. Okay, if x is a normal variate with mean 30 and standard deviation 5, find the probabilities that 26 less than or equal to x less than or equal to 40, x greater than or equal to 45. We'll see this. Here, what is given? Mean. Mean is given to us, mu is equal to 30, and standard deviation sigma is also given to us 5. Now, so the basic step for finding the probabilities, first we need to convert the x values in terms of z. Okay, first we need to convert x values into z values. Then we use the tables to find the area, and we will find it, right? So what is the value we need to find here? First of all, 26 less than x less than or equal to 40. So I am taking x is equals to 26. Corresponding to x is equals to 26, what is the value I need to get for z value? So x is equal to 26, then z is equal to, the formula is x minus mu by sigma. So I am substituting the values in this formula. I am getting sigma is equal to 26, z is equal to 26 minus 30. X is 26, x is 26, mu is 30, sigma is 5. So 26 minus mu 30 by sigma 5. After calculating, we get it as, use calci to calculate this value. So after calculating, we get it as minus 0.8, right? And when x is equals to 40, if we take x is equal to 40, then z is equal to 40 minus 30 by 5. After calculating, we get it as 2. So therefore, p of 26 less than x less than 40 takes into the z form. P of minus 0.8 less than or equal to z less than 2. Now you need to observe minus 0.8. Where we locate minus 0.8? Left side of z is equal to 0. So this is the point minus 0.8. Now less than 2. 2 is positive side of, here it is not visible. So here it is. Exactly at this point 2 is there. Now we need to find the area between these 2 points. So area between these 2 points is nothing but this, the total area. Okay, so we can add these two values. So we can write it, rearrange it as, we can take the 0 as the base value to find the areas. 0 we can take 0 as the base value. Okay, so from 0 to minus 0.8, minus 0.8 to 0 to 0 to 2, that means we are calculating the total area. That means we need to add these two areas. That means p of minus 0.8 less than or equal to z less than or equal to 0 plus p of 0 less than or equal to z less than or equal to 2. So this can be written as p of 0 less than or equal to z less than or equal to 0.8 can be taken as a of area of, that means area under minus 0.8. We can also represent like this, area under minus 0.8 plus area under 2, because we are evaluating the total area from minus 0.8 to 2. Now area is not negative. A of minus 0.8 is nothing but area of 0.8, area of 0.8. Okay, because area is not negative, area is always positive. We are calculating the area. So the negative represents only the location. Okay, location of the area. Negative means the location where it is located. Okay, so but it is, the while calculating we have to consider it as positive. Now we need, here a of 0.8 value is here 0.2881. Where we get it? This will be get from the tables. Okay, we need to search out in table. There is a table, normal distribution table, where the z values are in the first column and the area values in this horizontal row. We can find. I will show you in the last slide. So just remember this value 0.2881. 0.2881 is the area for 0.8, and 0.4772 is the area for 2. Okay, now we adding these two values, we will get it at 0.7653. Okay, like this we will find the yeah, areas, probabilities, right? So while x greater than or equal to 45, we'll see x greater than or equal to 45. For x greater than or equal to 45, we need to convert same, the process is same. So we are taking z is equal to x minus mu by sigma, that is equal to x value is 45. We are substituting mu is equal to 30 by, and standard deviation is equal to 5. After calculating, we are getting 3. Okay, p of x greater than or equal to 45 changes to p of z greater than or equal to 3. So how do we write p of z greater than or equal to 3? Z greater than or equal to 3. That means over 3. We need to find the area over 3. So this is our normal curve. This is the normal curve. This is our normal curve, right? So here z is equal to 0. We are taking z is equal to 0. This is the standard point. And what we are getting, z greater than or equal to 3. Greater than means right side of 3. Less than means left side of 3. Okay, in between means like this 0 2. Okay, the under the area, right? Z is equal to 0. Now z greater than 3. We need to find this area. To find this area, what we need to do, we take the base point 0. Oh, sorry. Yeah, I'm going to the next slide. No problem, no issue. So here we will see the one more problem. For a normal distributed variate with mean 1 and variance 9, find the probability that 3.43 less than or equal to x less than or equal to 6.19 and minus 1.43 less than or equal to x less than or equal to 6.19. Now solution. Given mu is equal to 1, rho square. Rho square is nothing but variance. Variance we denote it as rho square, that is equal to 9. So sigma, from the variance we get sigma standard deviation, that is equal to 3. So now clearly, as we discussed before, corresponding to the x values we are finding the z values. This is the process we need to follow, and we are getting the values. Z value is 0.81 and z value is 1.73. In between 0.81 1.73 we need to calculate. So area of 1.73 minus area of 0.81. So the table value of 1.73 is 0.4582 and the table value of 0.81 is 0.2910, which gives the answer 0.1672. Now second value is minus 1.43 less than or equal to x less than or equal to 6.19. This is also will do the same process, right? So first we take x is equal to minus 1.43. According to the x values, we are getting the y values as minus 0.81 less than or equal to z less than or equal to 1.73. So here it is minus 0.81 and here it is 1.73. We are calculating the entire area. So for entire area, we need to add these two values, area of 0.81 plus area of 1.73. So by using the table, we are getting the value 0.4582. So 0.81 value we need to find 0.173 value. So 0.81 value is 0.4582. 1.73 value is 0.2910. Just we will see how do we calculate 0.81 in the table, which is given in the last slide. 0.81. See here 0.81 I need to calculate. So where is 0.1? This is the table. Please observe this table. So these are the values of areas, and these are the z values. Corresponding to the z value, the decimal point where is located we need to observe, and the exactly the point we need to take. So 0.8 is here. 0.81 we need to calculate, say 0.81. So 0.81 means this is the 0.01. Okay, so exactly opposite to the 0.01, this is the area. This is the area for 0.81. So for example, if we need to calculate 0.82, this is the value, like that. For example, if we want to calculate 1.52, 1.54 say, 1.54 say, this is 1.5 and this is 4. So this is the value of 1.54, 0.4382. Isn't it? Is it clear, all of you? So like that we will get all the values from the table. There is no need of calculation. The beauty of normal distribution is there is no need of doing the integration. Actually, to find the probabilities, we need to do the integration for the corresponding function. But it is very tedious to do the integration for corresponding functions in normal distribution, because the formula is e to the power of minus 1 by 2 into x minus sigma by x minus mu by sigma whole square. So it is very difficult to calculate by actual integration. So we need to use this table for calculating the areas, right? So this is all about normal distribution. Thank you very much for listening the class. I hope you understand this concept. So we will meet in the next class. Thank you. Bye.